path that objects take when they're thrown or shot, like a football being thrown, is in a parabolic shape. It's got some initial velocity, so it takes off, but then gravity pulls it back down. So we have a formula to represent this path, and it will tell us the height at any given time is -16, that has to do with the gravity, times t squared, plus the initial velocity, v sub naught, that's when it was first left the hands of the quarterback or the barrel of the gun, times t, plus h sub naught, and h sub naught again is the height where you started from. Sometimes you're not on the ground, sometimes you're up on a platform. So we want to solve this problem. A ball is thrown vertically from the ground with an initial speed of 160 feet per second. So when will the ball strike the ground? Well, if it's going to strike the ground, then that means its height is 0, so we'll use that for the h. That's the question of when will the ball strike the ground. Our h would have to be 0. -16 is a number. When is asking for the time, so we're going to leave t squared, plus we have an initial velocity because it told us that the speed when it was first initially thrown has 160 feet per second times t, and it's thrown vertically from the ground, so we don't have any additional height added to the problem. We're going to try and solve this problem. Typically we would, when we have more than one variable, try and factor. So we can factor out a -16t, and that would leave us with a positive t minus, all important, a negative times a negative is positive, 10t. We've already factored out the t. So now we can use the zero product property, and we can say -16t is equal to 0, or t minus 10 is equal to 0. And yes, in fact, t is 0. At no time passed, you're on the ground, and so it's already on the ground. But we wanted not this time that it was on the ground, but over here when it ended on the ground again a second time. So solving for t, we get that t is equal to 10. And t is given to us in seconds. So we always answer word problems with words. So the answer to part A is that the ball will strike the ground in 10 seconds. What about part B? What is this asking us to do? When will, so again that's a time, when will the ball be 400 feet above the ground? So for part B, we don't want the h to be 0. We're not on the ground. We want it to be 400 feet above the ground. So we'll let that h be 400 is equal to -16t squared plus, and again it's the same situation, that they haven't changed it, so there was an initial speed, initial velocity of 160 feet per second. Solving this equation, well, we are not going to be able to just factor out what's common because it's not set equal to 0. So let's do that first. Since this 16t squared is negative, I'm going to add a positive 16t squared and subtract a negative 160t from both sides. We now have 16t squared minus 160t plus 400 is equal to 0. Make our life a little bit easier. Let's factor out 16. So that'll give us a t squared minus 10t plus 25 equals 0. And then we can factor that a little bit more. 16, two sets of parentheses, a t in the front of both of them. Let's look to see that the signs are the same, but they're both negative. So let's subtract in both of these factors of 5. And I think when I smile there, I get a negative 10t in the middle, just like I wanted. So again, using the zero product property, we can say one of the factors, 16, is 0, but we know it's not. That's why we say or t minus 5 equals 0, or t minus 5 equals 0. But that's saying the same thing twice. So here, solving for t, we get 5. After 5 seconds, the ball will be 400 feet above the ground. Well, actually, if you think about that, let's see. It was going to take 10 seconds for it to hit the ground again, and after 5 seconds it's 400. I think that indicates that we're right here at the highest point. We've gone 5 seconds, we'll go another 5 seconds, and we're back on the ground.